Hello. Okay, let's start. Okay, as usual, I will write my notes and I'll try to explain to you guys as best as I can. But I won't show you guys my notes. I will put it on a separate. Wait, let me set up my notes. So yeah, and the path today that I picked is API testing. I never tried testing APIs like pen testing APIs, so this should be new. Okay, let's start then. To start API testing, you first need to find out as much information about the API as possible to discover its attack surface. To begin, you should identify API endpoints. These are locations where an API receives requests about specific resource on its server. For example, consider the following GET request. So the GET request is asking for the API of books. The API endpoint for this request API books. This results in an interaction with the API to retrieve a list of books from the library. Another API endpoint might be, for example, API books mystery, which will retrieve all of the mystery books. Once you have identified the endpoints, you need to determine how to interact with them. This enables you to construct a valid HTTP request to test the API. For example, you should find out information about the following: the input data the API processes, including both compulsory and optional parameters, the types of requests the API accepts, including supported HTTP methods and media formats, rate limits, and authentication mechanisms. Okay. So I think the first one requires us to fast forward the parameters, because usually we wouldn't have the info about the parameters unless there's a usage in the website. Then we can try other HTTP methods and media formats, and then check for rate limits so they can't spam. So this is like a brute force or DOS, right? I'm not really sure, but I'll try to keep it on my notes. Okay, let's continue. API documentation. APIs are usually documented so that developers know how to use and integrate them. Documentation can be in both human-readable and machine-readable forms. Human-readable documentation is designed for developers to understand how to use the API. It may include detailed explanations, examples, and usage scenarios. So this is like a wiki, right? Machine-readable documentation is designed to be processed by software for automating tasks like API integration and validation. It's written in structured formats like JSON or XML. API documentation is often publicly available, particularly if the API is intended for use by external developers. If this is the case, always start your recon by reviewing the documentation. Documentation, okay. Interesting. Let me keep that. Put it on my notes. Discovering API documentation. Even if API documentation isn't openly available, you You may still be able to access it by browsing applications that use the API. To do this, you can burp scanner to crawl the API. You can also browse applications manually using Burp's browser. Look for endpoints that may refer to API documentation. For example, API, Swagger index.html, OpenAPI JSON. If you identify an endpoint for a resource, make sure to investigate the base path. For example, if you identify resource endpoint, API, Swagger, v1, version 1, users 123, then you should investigate the following paths. Oh, okay. You can also use a list of common paths to find documentation using intruder. Oh yeah, this is nice. Exploiting an API endpoint using documentation. To solve this lab, find the exposed API documentation and delete Carlos. You can log into your own account using the following credentials: winner, Peter. Okay. Let's try accessing the lab first and also open our burp. Okay, let's open our browser. So I'm pretty sure we are gonna use the winner Peter account again, right? Yeah. So I think we can use the guest that we found and use a, what is it called again? Intruder. So how can we find it? It's probably right here, right? Can add, wait. Let's copy all of them. Then we can try, so we can get this part, paste, yeah, this should be it. So we can try to access and find a hidden API. Hopefully it works. Why is it broken, man? So it does have API. Interesting. So do we? Let's try accessing it then. Peter. Why is it so laggy? What if we give it? So we can try to view the options. Method not allowed. What about delete? Then we delete the user Carlos. Maybe this is how it works. Oh, okay, interesting. So we leak the API by viewing the function. Cool. So we didn't even need the gist. So let's see the solution. Oh, so they checked the HTTP story. So I think my way is better because other than the HTTP story, mine is actually easier to do because it's more simpler. Yeah, nice. Using machine readable documentation. You can use a range of automated tools to analyze any machine readable API documentation that you find. You can use the burp scanner crawl to crawl and audit OpenAPI documentation or any other documentation in JSON or YAML format. You can also parse OpenAPI documentation using the OpenAPI parser app. What's this? It's this from Burpsit. Oh yeah, it's from portswigger also. Oh, it's an extension. Interesting, I'll keep that in mind. You may also able to use a special tool to test documented endpoints such as Postman and SOAP UI. Oh, Postman can be used to test the documented endpoints also? I didn't know about that. Identifying API endpoints. You can also gather a lot of information by browsing applications that use the API. This is often worth doing even if you have access to the API documentation, as sometimes documentation may be inaccurate or out of date. You can use burp scanner to crawl the application and manually investigate interesting attack surface using burp's browser. While browsing the application, look for patterns that suggest API endpoints in the URL structure, such as API. Also look out for JavaScript files. These can contain references to API endpoints that you haven't triggered directly via the web browser. Burp Scanner automatically extracts some endpoints during crawls, but for more heavyweight extraction, use the JS Link Finder app. You can also manually review JavaScript files in Burp. But there are so many extensions that we need to remember. But it's for... Wait, I'll just write that here. Interacting with API endpoints. Once you have identified API endpoints, interact with them using the burp repeater intruder. This enables you to observe the API behavior and discover additional attack surface. For example, you can investigate how the API responds to changing the HTTP method and media type. As you interact with API endpoints, review error messages and other response closely. Sometimes this includes information that you can use to construct a valid HTTP request. Identifying supported HTTP methods. The HTTP method specifies the action to be performed on a response on a resource. For example, get receives data, patch partial changes, options, receives information on the types of request methods that can be used on a resource. An API endpoint may support different HTTP methods. It's therefore important to test all the potential methods when you are investigating API endpoints. This may enable you to identify additional endpoint functionality, opening up more attack surface. For example, the endpoint API task may support the following methods. Get API task, yeah, creates a new task because it's post and delete. It's the same to what we did before. Delete. You can also use the built-in HTTP verbs list in Verb Intruder to automatically cycle through a range of methods. Ooh, interesting. When testing different HTTP methods, target low priority objects. This makes sure that you avoid unintended consequences. For example, altering critical items or creating excessive records. Yeah. So when testing the HTML methods, you should test on the less important part of the website and don't try to test it on the important APIs because it could alter the important data and stuff. Identifying supported content types. API endpoints often expect data in a specific format. They may therefore behave differently depending on the content type of data provided in a request. Changing the content type may enable you to trigger error that disclose useful information, bypass fault defenses, take advantage of differences in processing logic. For example, an API may be secure when handling JSON data, but susceptible to injection attacks when dealing with XML. To change the content type, modify the content type header. Then reformat the request body accordingly. You can use the content type converter app to automatically convert data submitted with a request between XML and JSON. Interesting. There's so much to write in the notes. I'll probably notes. To solve this lab, exploit a hidden API endpoint to buy a lightweight leather jacket. You can log in to your account using the following credentials. Winner Peter. Use error messages. How HTTP methods are used. How changing HTTP method can reveal additional functionality. Okay, let's try. And hopefully we can solve this pretty fast. I don't want to spend a lot of time on these labs. Okay. So let's log in to Winner Peter. Then we have 0 store credit. Then let's view the details. Add to cart and view our cart. And let's try placing our order in. Oh wait, we can't do that because it has CSRF. Let's check to intercept. Insufficient funds. What if we do options? Method not allowed. Hmm. What about coupons? Maybe you can find coupons. Invalid coupon. What if we try to access? Let's try this, then let's try accessing the cart. What happens? Product ID. Interesting. Wait, I think the cart method is just adding the quantity, right? Let's try. Yeah. How can we? So it's not through an API anymore. To intercept. Response. So it doesn't work anymore. So I think the main focus is the place order, right? That's the most. So other than post, what about if we get the checkout? Method not allowed. Okay. So what are the methods? Let's try to see. Intruder. I think it has, right? Oh. Well, let's just find it on Google then. HTTP methods. Head. I don't think head will bring us any info. But let's try. Method is not also not allowed. Interesting. What if post put? Try put it. Intercept. Method also not allowed. Is it not in this part? What about connect? Trace. Trace is also interesting. So I actually have no idea on how can we solve this challenge. All of them are not allowed. So get gives us our card, right? But trace, what about trace? Not allowed. Put also not allowed. Delete. Patch. Interesting. What if we try to pause and give it a product ID, right? Is this the way? Forgot. So it's asking for a product ID. So the product, what is the product ID? I forgot again. Oh, it's one. Okay. It's one. So what is radial about? Let's try. So Reddit is actually pretty interesting because it's so weird. Wait, what? Card. All of them are in their value. So it has to be card. Invalid? Isn't that the same? Oh, I don't think it's strings. It's still wrong. What's the difference? It's basically the same, isn't it? Yeah, it's the same. Can we do like a integer for flow? Very funny. So I'm confused. I think I'm just gonna use the solution. For real? Oh yeah, I forgot about the browser. Oh shit. That was my bad actually. Let's try accessing so it doesn't uh, oh yeah, it's asking for price. So what if you try to access it on the wait what if we try to access it here? Try going down. Products not found. API also not found. Okay, so yeah, let's try options then. Method not allowed. Okay. So we can do get, right? That was the original one. What if we can do put or patch? That would be cool. Oh. Only application JSON content type is supported. So wait, let me see these examples. Yeah, it's correct. Price, let's set it to 0. There we did it. Let's see. Nice. Let's add it to cart. Then pay. Oh yeah, but I'm not gonna lie. I solved it because I saw the the hint, the solution. So my bad, guys. We don't expect the API to be used to view the price. I thought the main focus was at the cart because that's where the buying logic is. So that's my bad. Nice. Okay, let's continue. Using intruder to find hidden endpoints. Once you have identified some initial API endpoints, you can use intruder to uncover hidden endpoints. For example, consider a scenario where you have identified the following API endpoint for updating user information. To identify hidden endpoints, you could use the group intruder to find other resources with the same structure. For example, you could add the payload update position of the path with a list of common functions such as delete and add. When looking for hidden endpoints, use word lists based on common API naming conventions and industry terms. Make sure you also include terms that are relevant to the application based on your initial record. Yeah, so what this means is we can try to find the hidden API endpoints, like we could brute force this part of the endpoint using a word list, probably. When you're doing API recon, you may find undocumented parameters that the API supports. You can attempt to use these to change the application's behavior. Burp includes numerous tools that can help you identify hidden parameters. Burp Intruder enables you to automatically discover hidden parameters, using our list of common parameter names to replace existing parameters or add new parameters. Make sure you also include names that are relevant to the application based on your initial record. Yeah, so this is basically fuzzing for parameters to try and get the data. The Param B app enables you to automatically guess up to 65,000 param names per request. Per request, that's insane. Paraminer automatically guesses names that are relevant to the application based on the information taken from the scope. The content discovery tool enables you to discover content that isn't linked from visible content that you can browse to, including parameters. So this is actually pretty interesting. So I'll put it on my notes again. Nice. Mass assignment vulnerabilities. Mass assignment, also known as auto-binding, can inadvertently create hidden parameters. It occurs when software frameworks automatically bind request parameters to field on internal object. Mass assignment may therefore result in the application supporting parameters that were never intended to be processed by the developer. Identifying hidden parameters. Since mass assignment creates parameters from object fields, we can often identify these hidden parameters by manually examining objects returned by the API. For example, consider a patch API users request, which enables users to update their username and email, and includes the following JSON. A concurrent get API users 123 request returns the following JSON. This may indicate that the hidden ID and sysadmin parameters are bound to the internal user object, alongside the updated username and email parameters. Yeah, so then we can try to patch we can add the JSON data below to have a sysadmin and events. vulnerable, then we can change the SAdmin. Testing mass assignment vulnerabilities. To test whether you can modify the enumerated SAdmin parameter, add it to the patch request. In addition, send a patch request with an invalid SAdmin parameter value. If the application behaves differently, this may suggest that the invalid value impacts the query logic, but the value doesn't. This may indicate that the parameter can be successfully updated by the user. You can then send patch requests with the SAdmin parameter to set it to true, then try to exploit the vulnerability. If the SAdmin is true, the request is bound to the user object without adequate validation and sanitization. The user winner may be able to incorrectly granted admin privilege. To determine whether this is the case, browse the application as winner to see whether you can access admin functionality. Ooh, interesting. This sounds fun. So let's try. It's taking so long to load. Okay. So I'm just gonna try to intercept the login. Oh, it has a CSRF. I don't think this is the part that we should test, but let's just hear it. Why not? Yeah, it's not it. Yeah, no worries. So let's try changing the email. So I'm pretty sure this is the part that we need to test. Let's just intercept the response. Intercept again. ID winner. Okay, so it's not this. What if we intercept this part? So that's not it. What about, let's try intercepting the few details again. Okay, I'm pretty sure this is not it. Interesting. I think I saw the API checkout. Let's check that out also. So if you can see here, when you place the order, we only see the product ID and the quantity. But if we check the API checkout again, it has an item price. So what if we put this item price below the quantity, then set it to 0? Then what happens? Let's try. So it doesn't work. Let me try one more time. Let's set it to A and see the, just send it to the repeater. So it doesn't work. Product ID, name, jacket, quantity. What is this percentage? What if we put this on 100 and then post it again? Then we can delete this part, then add the quantity to 1. What happens? Oh, so that's actually very interesting. So, okay, that's cool, I guess. Nice. Let's see the field solution. Wait. Oh yeah, I didn't see the chosen discount part because it's, yeah, I should have used the pretty print. Yeah, it doesn't cost an error. Interesting, so it's actually pretty fun. So what I want to check is, what if we set the percentage to the string? So what happens is, so when we change the product price, right, nothing happens in the application. So when we change the chosen product and it gives us an error, that this means that this is also loaded into the API. That's what I think the challenge mean. Nice. The solution mean. Let's continue. So, preventing vulnerabilities in APIs. When designing APIs, make sure that security is a consideration from the beginning. In particular, make sure that you secure your documentation if you don't intend your API to be publicly accessible. Ensure your documentation is kept up to date so legitimate testers have full visibility on the API attack surface. Apply an allow list of permitted HTTP methods. Validate the content type that is expected from each response or request. Use generic error messages to avoid giving away information that may be useful for an attacker. Use protective measures on all versions of your API, not just the current production version. To prevent mass assignment vulnerabilities, allow lists the properties that can be updated by the user, block lists sensitive properties that shouldn't be updated by the user. Yeah, it's interesting. This is similar to whitelist and blacklist. So I'll put that. Yes, I'm learning web security, man. Yeah, I feel like it's very useful because the goal of why I am pushing the portswigger. So what I'm doing is I'm pushing this website called Portswigger Academy. It provides the web exploitation, so it's only focusing on web pen testing. Yeah, the goal is for me to get the certification for job. Yeah, it's the same probably. I feel like module scripts and API could be the same. It just has a different name probably, or similar. It's very similar probably. I know nothing about Roblox, so I don't know. Yeah, it should be the same. Security stuff to the game, probably. I think API based security is the same across applications. Like in Android applications also, they also use APIs. It's the same instead of software in general. Yeah, I could probably, but I feel like games, I think they have a different focus of the security stuff. I don't know. Other than the data, we need to also focus on the cheaters. Like we need to focus on the where the cheaters can access. But I know nothing about the security in Roblox. Okay, so I don't know. I'm not 100% sure that I could implement the same security, like all of the security to the game, but maybe I can implement a similar security to the game. Probably. Oh, I actually can show the chat, but if you want to see it's like this, so it's very little. This is the chat that I can see. And I haven't even logged into the chat window. To be honest, I don't even know how to put chats on my OBS because I'm using OBS, right? I have no idea. I'll try to research it. Okay, thank you, man. Okay, let's continue. Server-side parameter pollution. Interesting. Some systems contain internal APIs that aren't directly accessible from the internet. Server-side parameter pollution occurs when a website embeds user input to server-side requests to an internal API without adequate encoding. This means that an attacker may be able to manipulate or inject parameters which may enable them to, for example, override existing parameters, modify the application behavior, access unauthorized data. You can test any user input for any kind of parameter pollution, for example, query parameters, form fields, headers, and URL path parameters may all be vulnerable. This vulnerability is sometimes called HTTP parameter pollution. However, this term is also used to refer to web application firewall WAF bypass technique. To avoid confusion in this topic, we'll only refer to server-side parameter pollution. In addition, despite the similar name, this vulnerability class has very little in common with server-side parameter pollution. Interesting. So let's continue testing for server-side parameter query string. Okay. To test for server-side parameter pollution, the query string. Place query syntaxes, characters like hashtag and equal sign in your input and observe how the application responds. Consider a vulnerable application that enables you to search for other users based on their username. When you search for other user, your browser makes the following request: get user search. So we are using the name Peter, and it will redirect us back to home probably. To retrieve the user information, the server queries an internal API with the following request: get users search name Peter and public profile equals true. Okay, interesting. Truncating query strings. You can use a URL encoded character to attempt to truncate the server's side request. To help you interpret the response, you could also add a hashtag character. For example, you can modify the query string to the following: the front end will try to access the following URL. It is essential that your URL encode the hashtag character, otherwise the front end application will identify and it won't be passed to the internal API. Oh, insane! So we actually have to URL encode the character so it doesn't. Oh, review the response for clues about whether the application has been truncated. For example, if the response returns the user Peter, the server-side query may have been truncated. If an invalid name error message is returned, the application may have been treated full as a part of the username. This suggests that the server-side request may have not been truncated. If you are able to truncate the server-side request, this removes the requirement for the public profile files field to be set true. You may be able to exploit this to return non-public user profiles. So, wow. So let me save this part. Then I'll save this part. You can also use the URL encoded AND character to attempt to add a second parameter to the server-side request. For example, you can modify the query string to the following. This results in the following server-side request in the internal API. Review the response, replace an additional parameter is... Wait, what? Injecting file parameters. If you are able to modify the query string, you can then attempt to add a second file parameter to the server-side request. For example, if you have identified the email parameter, you could add it to the query string as follows. This results in the following server-side requests to the internal API. Review the response for clues to the additional parameter is sparse. Whoa, so basically we have the server-side APIs and the client-side probably. So the client-side wouldn't have the email parameter, but it will pass this get the request to the backend to the server-side API. Then the server-side API will see the %26 as the AND. Ooh, this is so cool. Overwriting existing parameters. To confirm whether the application is vulnerable to server-side parameter pollution, you can try to override the original parameter. Do this by injecting a second parameter with the same name. For example, you could modify the query string to the following. So when we search for Peter, we can give it two names. Yeah. The internal API interprets two name parameters. The impact of this depends on how the application processes the second parameter. This varies across different web technologies. For example, PHP parses the last parameter only. This would result in the user search for Carlos. ASP.NET combines both parameters to result in a search for Peter and Carlos, which might result in a valid username error message. Node.js parses the first parameter only. This will result in a user search for Peter, giving an unchanged result. If you are able to override the original parameter, you may be able to conduct an exploit. For example, you can add name administrator to the request. This may enable you to log in as an administrator user. Oh yeah, it's interesting. Let me copy that. So I'm still trying to understand, like, I don't think I understand this well. I'm pretty sure I'm not even able to. Never mind. I think I'm able. Let's try. To solve the lab, log in as the administrator and delete Carlos. Okay, let's try. So this sounds like a very fun topic because it sounds very cool. So let's try. So we don't have any accounts, so no winner Peter. So probably the pollution is probably at the login page. But let's try to log into winner Peter. Okay, so winner Peter is not available. So let's try accessing website inside of our verb. And let's try for winner Peter. Winner Peter. Then intercept the then okay, this is actually a bit hard. I have no idea on how to bypass this. So we have no counts for real. Okay, let's try. I need to try to solve this. So let's get the winner Peter. Let's just put A and A. And what if we put the... Let's open up. Wait, I can't open it here. Try opening the cyber chat. I don't think I need cyber chef. I have my notes, so let's try giving it a %. Foo. And let's see the response. So what does it give? I want to render so it's easier to see. Invalid username or password. That's a bummer. What if we use the N one now? Do we need to find like the hidden parameters? And username equals administrator. So it gives us the it's knowing if we need to fuss. There's nothing here, right? Yeah, probably no. What about Carlos? Oh, interesting. What if we try to do it like this? I want to see the responses. What does it give? I don't think this will work, but let's try. Carlos and the username is also administrator. Let's do intercept administrator. Yeah. So it doesn't work. Wait, let me try to read the hashtag one again. Oh, interesting. So let's try to check that out. So the hashtag is only used to be the so let's try administrator. So this should return a true. Okay, but what about if we try to access administrator, then we try the hashtag foo. Invalid username, so it doesn't work. What about the and? Username is Carlos. Invalid username. So it doesn't work here, so it's not here. Let's try. I'm a bit confused, so I think I'm just gonna check the solution because I quit. Oreo? I didn't see that? Didn't I check that already? Wait, let me... Can I clean all of them? Can I delete all of this data? And select all of them. Clear history. Yeah, nice. So let's try changing the account. Forget password, administrator, submit. It doesn't ask for. Let's try accessing it. Oh, it does has. So let's view the interesting. So maybe we can pollute that. Can we? Didn't it use a CSRF? Oh, it doesn't. What? I thought it was using CSRF. See? Can we though? Oh, so it doesn't use CSRF. Oh, we need to actually add the CSRF. But it's consistent. Yeah. So what to do? But I tried it, right? Didn't it not work? Wait, I tried this before. See? Is it different? Oh, it's double encoded. Oh yeah, because in the JS it uses Arial encode, so that's why it doesn't work. Okay, I understand now. What about if I put and here? Still invalid. We put an equal here. What happens? Still invalid. I see no difference though. I don't understand the difference. Let's bring that to the repeater. And the difference is only the constant, right? If I put it like that, it's basically the same. Yeah, it's actually the same. Oh, but the return is different. Forward. See, it shows invalid username, but actually at the back end gives a parameter not supported. What if we put username Carlos? So okay, interesting. What about the foo? So it's actually %23 foo, field not specified. And username administrator. So the foo works. Interesting. Oh, field. Does field use field? Let's try equals a. Oh, it has a backup. Oh. What's happening? Or do we need a hashtag at the back? Oh, for the error. Okay, I understand it now. So can just delete this part and it's the 26, right? Yeah. Field equals a. What about this? Parameters not supported. It doesn't work. Invalid field. One. Invalid field. Oh yeah, because we found that email is working, right? So in the repeater, so let's delete this too. So the field is email, then doesn't help. Yeah. Okay, so this challenge is actually very, very hard. I still need to understand the field. Okay, this is very interesting. Okay, let's continue. Oh, that was very, very, very hard. Wait, I'm gonna take a break for a minute. I want to go to the toilet. Okay, let's continue. Testing for server-side parameter pollution in REST paths. A RESTful API may place parameter names and values in the URL path rather than query string. For example, consider the following path: API users 123. The URL path might be broken down as follows: API is the root API endpoint, users represent the resource. In this case, users 123 represents the data, right? The parameter, yeah. Identifier. Consider an application that enables you to edit the user profiles based on their username. Requests are sent to the following endpoint. Yeah. This results in the following server-side requests. An attacker may be able to manipulate server-side URL path requests, path parameters to exploit the API. Test for this vulnerability, add path traversal sequences to modify the parameters and observe how the application responds. You could submit URL encoded as the value of the name parameter. Oh yeah, I thought about that from here. This may result in the following server-side requests. If the server-side client or backend API normalize this path, it may be resolved to... Interesting. Save that. Okay. Is this the same? Or query string? Path. Okay. So we know the query string, path, and now we are testing for server-side parameter pollution in structured data formats. An attacker may be able to manipulate parameters to exploit vulnerabilities in the server's processing of other structured data formats, such as JSON or XML. To test this, inject unexpected structured data into user inputs and see how the server responds. Consider an application that enables users to edit their profile, then applies their changes with a request to a server-side API. When you edit your name, your browser makes the following requests. So they pass the parameter name to the my account endpoint. This results in the following server-side requests. Okay. You can attempt to add the access level parameter to the request as follows. Oh yeah, this is similar to SQL injections, right? But we are injecting the JSON or the XML data. If the user input is added to the server-side JSON data without adequate validation or sanitization, this results in the following server-side requests. This may result in the user Peter being given administrator access. Information on how to identify parameters that you can inject to the query string. See defining. Okay, it's basically fuzzing the string parameter again. Okay, let's continue. Testing for server-side parameter pollution in structured data formats continued. Consider a following example, but where the client-side user input is JSON data. When you edit your name, your browser makes the following request. Okay, so now we are the ones that give the JSON data. This results in a server-side request. Yeah. You can attempt to add the access level parameter as follows. If the user input is decoded, then add it to the server-side JSON data without adequate encoding. The results in the following server-side request. So it's basically the same, right? But you just need to add the backslash so that the server knows that this is the double tick and doesn't close this one. Interesting. Again, this may result to the user Peter being given administrator access. Structured format injection can also occur in responses. For example, this can occur if the user input is stored securely in the database, then embedded into a JSON response from a backend API without adequate encoding. You can usually detect and exploit structured format injections in responses in the same way you can in requests. Okay. This is an example below. It's in JSON, but server-side parameter pollution can also occur in any structured data format. For example, in XML. See the X include attack section in the XML external entity injection topic. I'll find it later. Let me put it on my notes. Dang, I'll go fishing in the chat. When ya? Testing with automated tools. Verbs include automated tools that help you detect server-side parameter pollution vulnerabilities. Verb scanner automatically detects suspicious input transformations when performing an audit. This occurs when an application receives user input transferred in some way, then performs further processing on the result. This behavior doesn't necessarily constitute a vulnerability, so you'll need further testing using the manual techniques outlined above. Okay. For more information, see the suspicious input transformation and issue definition. Okay, so to prove that this is a vulnerability, you need to actually explain the impact of the vulnerability. Okay. You can also use the backslash powered scanner the app to identify server-side injection vulnerabilities. The scanner classifies inputs as boring, interesting, or vulnerable. You will need to investigate interesting inputs using the manual techniques outlined above. For more information, see the backslash powered scanning. Hunting unknown vulnerability classes. Interesting, I'll keep this. Preventing server-side parameter pollution. To prevent server-side parameter pollution, use an allow list to define characters that don't need encoding, and make sure all the user input is encoded before it's included in a server-side request. You should also make sure that all input adheres to the expected format and structure. Okay, so basically we can use an allow list on characters that don't need an encoding, so it's basically the and sign, equal sign, yeah, that stuff. And also we need to make sure that the user input is encoded, so when the server takes the input, it's encoded. Yeah, and we should make sure so we can use like a checker so that the input from the user is in our expected format. Nice. Wait, let me put that on my notes. Finish. Okay, how many hours was that? Almost exactly 2 hours. Okay, nice. Okay, that's it for today. We finished the API testing. Nice. So we already finished file uploads, server-side vulnerabilities, API testing, path traversal, and also click tracking. Nice. That's it for today, guys, for today's stream. Hope you guys have a great day if you are watching. Thank you. See ya.